using Descartes' rule of signs. There is a straightforward way to determine the possible number of positive and negative real zeros for any polynomial function. If the polynomial is written in descending order, Descartes' rule of signs tells us of a relationship between the number of sign changes in f of x and the number of positive real zeros. So for example, the polynomial function below has one sign change. If you take a look at f of x is equal to x to the fourth plus x cubed plus x squared plus x minus 1. So if you take a look from here, this is where the sign changes from positive to negative because this was all positive. This tells us that the function has or must have one positive real zero. Now there is a similar relationship between the number of sign changes in f when the input is negative x and the number of negative real zeros. So if we plug in negative x into the function, we get negative x to the fourth, which gives us positive x to the fourth. We get negative x cubed, which gives us minus x cubed. We plug in negative x squared, gives us plus x squared. Plug in negative x gives us negative x and then minus 1. Well, let's take a look at how many sign changes when we have the input to be negative. Well, here is one sign change because that goes positive to negative. Then we have another sign change which goes from negative to a positive. And then we have another sign change which goes to positive to negative. So in this case, we can see that we have three sign changes. So this tells us that f of x could have 3 or 1 negative real zeros. Now, Descartes' rule of signs. According to Descartes' rule of signs, if we let f of x be the function or be a polynomial function with real coefficients, the number of positive real zeros is either equal to the number of sign changes of f of x or is less than the number of sign changes by an even integer. The number of negative real zeros is either equal to the number of sign changes of f of negative x or is less than the number of sign changes by an even integer.